Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to talk about Course 3 Geometry and Measurement. I have 3 pages of questions that a student sent in, and we're going to take care of some of these questions in the book. The reason why I'm sharing these slides versus my typical slides is because I'm not going to draw all this. It's gonna look not correct, and I can't possibly even begin to describe to you how much better these images are than the images that I would potentially have drawn. So, in this particular set of problems, the student has very specific questions. So I'm going to go ahead and circle a couple of them here. So question 11 and question 13. So we're going to start with those two, and then we'll move on. In both cases, the problems ask for volume. So volume, we want to make sure that we really fully understand what's happening with volume. We know that perimeter is kind of like the fence of an air of I don't know, like our house, right? It's the fence around our house. The area is kind of like the grassy field that's in our front lawn. And the volume is kind of like a swimming pool filled with water. We're looking at the water for the volume. In this particular case, we just have very oddly shaped swimming pools, and we want to find out how much water we're going to be able to put into these swimming pools. Um, with regard to formulas, the volume for any prism, and this goes for, and these are all of these shapes on this particular slide are all prisms because they have the same top and the same bottom. Because they have the same top and the same bottom, they're considered prisms versus cones. So just so we're on the same page, this is a prism. And this, even though they have the same bottom, because they don't have the same top, this blue one is a prism and this green one is a cone. Okay. So a cone is kind of like when something comes into one particular point where the top and the bottom are not the same shape. Okay, so the volume of any of these particular shapes is going to be the area of the base times the height of the shape. So for example, in this, it's not quite exactly the same, but in this triangular prism, that's number 11, we're going to find the area of the bottom triangle and multiply it by the height of my prism. So in this particular case, I'm going to find the area of this triangle and multiply it by this height over here. So that means you need to know the area of certain two-dimensional shapes. For example, so in here, this is the area of the base. Okay, so the area of a triangle, so the area of a triangle is 1/2 the base times the height. So in this particular shape, I know that this is my shape. I know this is a right angle. So this will be my height of 10 inches, and this will be my base of 13 inches. So I'm going to say it's going to be 1/2 times 10 times 13. I can do this math first and get 5, and then multiply that by 13 and get 65. So when I'm looking at the volume of this, my volume is going to be the area of the base, which is 65, times 9. And I'm not going to do that one in my head, although I probably can. 585 cubic inches. So it's written inches cubed, but it's read cubic inches. Okay. So because I know how to find the volume of any three-dimensional shape, I also know that this is a three-dimensional pyramid, right? I know how to find the volume of any of those pyramids. This is a pyramid, not a pyramid, a prism, not a pyramid. That was silly of me. I can go ahead and I can find the area of the base, which is, in this case, the area of the base is the circle. And I know that the area of a circle is pi r squared. I know that since the whole diameter from here all the way to here is 16 inches, I have to take that in half, right? So it's going to be pi times 8 squared. 8 squared is 64. Pi is going to be 3.14. That I'm definitely not doing in my mind. Sometimes when you're using a calculator, teachers say use the actual pi button instead of 3.14. But in here, because we're rounding to the nearest whole cubic unit, it doesn't quite matter because we're going to be off by point something instead of like 1 or 2. So for example, I did 3.14 times 64 and my answer was 200.96 versus if I did 64 times the actual pi button, I would end up with 201.0. Either way, I would round this to 201 anyway. Okay, and then I know that the height of my entire cylinder is 7 inches. So I would take that and multiply it by 7. And I would end up with the volume of my cylinder would be 1407.4 blah, 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 blah. I don't really care about the blah, 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 because I'm always going to look at just the number that's right here in order to get this fully rounded. So in this case, my volume is 1,407 cubic inches. That's my volume for this particular one. Okay, so let's see what else we have. Let's go to the next one. Okay. So the next problem that we have in here is 17. So 17, I'm going to actually go in and create a black surface over here so that I can write a little easier. Whoops, that's not what I wanted. Okay, here we go. So it says find the volume of a cylinder with diameter 11 and a height of 6.2. Explain why you chose the method you used. I'm not quite sure if there are multiple methods to find the, whoops. See, this is my drawing skills, just so we're on the same page. So we've got a cylinder. We know that the height is 6.2 feet. We know that the diameter is 11, so we're actually just going to draw the radius. The radius is half of 11, right? Half of the diameter. So 5.5 feet. I guess this is a pretty large cylinder because I'm 5 feet tall, so this is taller than me and longer, I guess deeper, wider than me. I don't know. Okay, so I know that the volume is always going to be the area of the base times the height. Well, in this case, my base is a circle. So I know that I need to find the area of the circle first, which is pi r squared. I know that my radius is 5.5, so I'm going to go pi times 5.5. Actually, we can just do that squared. So in this case, I'm going to go 5.5 squared times 3.14. And I'm going to get my area of the circle or my area of the base is this. Now here it doesn't say that we need to round, and I still used 3.14 because typically you're only going to be asked for 4 numbers after the decimal point. And since I already have 3 with the circle and I know my height has an additional 1, I know there's going to be 4 numbers after the decimal point anyway. And even if there is not, we're going to say that we're going to take the volume. I don't know why that has this thing over here. So the volume is going to be 94.985. And we're going to take that, we're going to multiply that by 6.2. So what you will see when you multiply these two on your calculator, you won't see the 0, but you know that 2 times 5 is 10. So really 0 will be the last number in this particular case. I'm not quite sure what it means by to explain why you chose the method you used. Because this is the way to find the volume of a cylinder, I guess. I don't know. That's a weird question. And then we want to make sure that we're putting cubic feet as well. Okay. So we're going to go to the next one and clear all of this. And then, okay. So the next one that we're working on is going to be problem 19, problem 21, and then problem 29. But that's, oh, that was just a review question. So that was not part of this volume set. Okay. So number 19 says, which has a greater effect on the volume of a cylinder, doubling the radius or doubling the height? Explain. So when we look at the volume of a cylinder, we know technically the area of the base, right, which is pi r squared, and we're going to multiply it by the actual height. Okay. So let's say I put in 5 for the radius and 5 for the height. So I'm going to end up with times 5 squared times 5. So without having to do any sort of math on a calculator, I know that 5 to the third power, because there's 2 5s here and then one more 5 here, I'm going to go, that's going to be 125 pi. That's my base. Now, in order for me to double the radius, so this one will be doubling the radius. So that means I'm going to have pi 10 squared times 10 squared times 5. So that's going to be 100 times 5. So this will give me 500 pi. And then doubling the height will be pi times 5 squared. So I'm going to go back to my original 5 squared times 10. So 5 squared is 25. 25 times 10 is 250. So I'm going to have 250 pi. So before I feel like I should have explained a little bit better before I went in to do an actual example. They want me to explain to them or to tell me or to tell them, hey, this is going to be a big greater effect on the volume. I don't particularly, let's say I'm the student, I don't particularly know. In order for me to be able to explain to you why something is a greater effect on a volume of the cylinder, whether it's the radius, doubling the radius, or doubling the height, I need to actually show you with numbers, because showing somebody something is a little bit easier to comprehend than just telling them, oh, it's going to be this, okay? So I decided to choose a number that is somewhat easy, but also not 1 or 2. I know my 5 tables, my 5 times tables, those are pretty easy for me. So those I decided to choose 5. I could have just as easily decided to choose 4 or 6 or 12 or 5,000, whatever. Any number would have worked, and any number would have given you the same answer, that doubling the radius is going to be greater than doubling the height. In this case, we see that my original volume is going to be 125. Doubling the radius would give me 500, and doubling the height would only give me 250. And that kind of makes sense, that doubling the radius would give me a larger number because I'm squaring that larger number. That larger number is going to show up twice versus the height will only show up once. Okay. So when you explain, you can use this as part of the explanation for the answer. Okay, then we have to find the volume of each prism. So in actuality, we can find the area of the base, which is this right here, and then multiply by the height, which is this right here. So in order for me to find the area of the base, I need to actually kind of like break it apart so that I can see what's happening. So I know this is 15, this is 20, this is 7.5. This is also obviously 7.5, and this is 10, and this is 10. I can say by looking at this that this particular image used to be a full rectangle. It used to be a 15 by 20 rectangle. So I'm going to find the area of this full 15 by 20 rectangle and subtract this portion that was kind of like taken off, cut off, bit off, whatever. So 15 times 2 is 330. So 15 times 20 is 300. So I've got 300 square meters. Now I'm going to need to subtract this 7.5 by 10, which is just 75 square meters, because that's the piece that was taken off. So 300 minus 75 is 225 square meters. That is the area of the base. That is my big B that I need for the volume. So for the volume, I'm going to have 225 multiplied by the height. And the height of this particular pyramid is, prism, sorry, I don't know why I keep saying pyramid, is 8 meters. So I'm going to take this 225 and multiply that by 8 and get that my volume is 1,800 cubic meters. And that is exactly, I mean, that's literally what it sounds like. We're always going to take, no matter what the crazy pants shape is, we're going to take the area of the base and multiply it by whatever the height is. In 22, we could do exactly the same thing. We would just need to find the area of this like upside down L and the triangle, add those two together, and then multiply it by whatever the height is, which in this case, I think is 3 centimeters. I hope that this video was helpful, and I look forward to seeing you in another video. Bye.